All right, here are solutions to written problem 5 for Math 252. What you are asked to do is figure out the indefinite integral of natural log of x cubed dx using integration by parts repeatedly, so maybe a little hint there. And so if we're going to be using integration by parts, I figured I'd make note of the integration by parts formula. So I'll reference this as I go through the solutions. And note that it says, suppose you do not know the antiderivative of natural log of x. And the reason I put that in here is because you might be able to, I'm not sure if this would work or not, but you might be able to solve this problem using integration by parts if you let u be equal to the natural log of x squared, and then the dv would be natural log of x dx. And if you did that, you would need to know the antiderivative of natural log of x dx, because you'd need to figure out what v would be equal to. And honestly, I'm not sure if that would work or not. It might work if you know the antiderivative of natural log of x, but I don't think it'll work as cleanly as the method that I had in mind for you guys doing. But maybe to save you a little time and frustration, I had you do it a different way. So at any rate, it kind of tells you in the first step, we're going to let u be equal to the natural log of x cubed, which I wrote right here. And therefore dv is just kind of a 1 as a placeholder, dx, or you can just write dx. And so our first step in order to use the integration by parts formula is I'll need to know what du is and what v is. And so for du, you got to think back to calculus 1, the derivative of natural log of x cubed. That's not super obvious. You got to use the chain rule. So first you take care of the exponent. So you got 3 times something squared. That something being the inner function. And then with the chain rule, you leave that function alone, but then you got to multiply by the derivative of that function. So that creates this 1 over x. And so du over dx equals that whole mess. So if I multiply both sides by dx, I get here. For v, it's easy, I guess. Maybe it's tricky because it's too easy. There's not really much to do. If dv equals dx, then v just equals x. You're like, oh, divide both sides by d. Not really, but I mean, I guess you could think about it that way. Really, it's more that there's a 1 here as a placeholder. And if you take the antiderivative of 1, you just get your variable, which is x. With these 4 parts, I can use my integration by parts formula. My integration by parts formula tells me that the integral of u dv equals uv. Here's my u and here's my v. Minus the integral of v du. So here's my v and here's my du. Oh, that works out kind of nicely, huh? Because the v and the du, the 1 over x and the x, will cancel each other out. So I can pull the 3 out in front and just say what's left is the integral of the natural log of x squared dx. Make sure you can follow all those different pieces. This 3 went here, this 1 over x and this x canceled each other out, and that brought me down here. And maybe now you can kind of see how this is going to work, right? This problem, what's left here, the natural log of x squared, is pretty similar to the original problem that was asked. The original problem that was asked was the natural log of x cubed. It kind of looks like by doing one iteration of this integration by parts, I was able to reduce the exponent by 1, which is awesome because it's getting me closer and closer to the right answer. Maybe I could just do this again, except this time I'm going to let u equal natural log of x squared. And if I let u equal natural log of x squared, then kind of process elimination, all that's left for dv is just the dx. And now I got to figure out du and v again. Although it's kind of the same thing as last time. Taking the derivative here would give me 2 times the natural log of x to the 1 power, which you don't have to write, times 1 over x dx. And v would again just be equal to x. And now if I go plugging that all in, I can leave everything except for this integral alone from the previous line. And then for this integral, I got that the integral of u dv equals u times v minus the integral of v du. And again, that nice thing happens where this x and this dx cancel each other out, and this constant I can bring out in front of the integral. And that gets me here. And now you can almost certainly see the progress that we're making. We started out with natural log of x cubed, and we brought that down to natural log of x squared. And now all I got to figure out is natural log of x. And I guess here this hint comes into play again. We can't just say that the natural log of x is, if you happen to know what it is, state it. What we instead have to do is use integration by parts one last time. This time we'll just let u be equal to the natural log of x, and dv is again dx. And now du finally works out really nicely. We don't have any chain rule going on here. The derivative is just 1 over x, and v is equal to x. So leaving everything alone from my previous steps, kind of trying to color coordinate so you can follow where all the pieces came from. And again, being really, really careful with the parentheses. That's probably the easiest way you could mess something up here. I want to apply my integration by parts formula on this little bit that's left here, the natural log of x. So the integral of u dv equals u times v, so x times the natural log of x, minus the integral of v du. And so v times du, which should have been 1 over x dx, by the way. V times du is just 1 dx. You don't even have to write the 1. I don't know, you could write it as a placeholder if you want, or you can just leave it out. And so now all that's left to do is to evaluate the integral of 1, which is just an x, and then maybe if you feel like it, clean some stuff up. So the antiderivative of the 1 gives us the x here. Let's see, we can close our green parentheses and then close our blue parentheses, and then I'll tack on the plus c. And there's nothing wrong with leaving your answer just like this, but I'm not gonna. What I'll first do is take this 2 and distribute it through these parentheses, or maybe the -2. So -2 times x natural log of x gives me -2x natural log of x. And then the -2 times the -x here gives me plus 2x. And now I don't have the green parentheses anymore, I just have the blue parentheses. And I can get rid of these blue parentheses in the next line by taking this -3 and distributing it through. So if the -3 hits this term, I get -3x natural log of x squared. And then if the -3 hits this term, then -3 times the -2 gives me a positive 6x natural log of x. And then finally, if the -3 hits the positive 2x, I get -6x, and I still have my c, which I didn't write on the previous line. That gets me here. I don't think I can go any further than this. I mean, I suppose all the terms have an x in them, so if you felt like it, you could factor out an x from each of the terms. I don't think I feel like it. I think I'm going to call that good for my answer, but really any of these are fine. So maybe I'll just end this here.